11.4 is on geometric sequences and series. So last time we talked about arithmetic sequences and series, which were when you were adding what we call a common difference to each term. So like something like 2, 4, 6, 8, 10, right? You're always adding 2. Now we're going to be talking about a geometric sequence, which is when you have like multiplying by the same thing. So maybe you have 2, 4, but then it goes 8, 16, 32, 64, right? So this is going to be something that we're multiplying by each time, and this number is called the common ratio. So in order to find the common ratio, you can take any term and divide by the term before it. So you could have A2 divided by A1. You could have A3 divided by A2. Really any term divided by the term before it. So A sub n divided by A sub n minus 1. Okay, but it's not always that complicated. You don't have to do that. Usually you can find what R is by just looking at the sequence. So when I look at this first sequence, 2, 4, 8, 8, 16, and so on, what am I doing to go from 2 to 4? What did I multiply by? By 2, right? And then I multiplied again by 2, and I multiplied again by 2. So yes, this is a geometric. And my common ratio is what I'm multiplying by each time. So my R is equal to 2. So see how that works? I could take any term, 16, and divide by the term before it, 8. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2, right? It still works that way. All right, so on the next one, if I have 5 over 3 times, or comma, 5 over 9, comma, 5 over 27, what am I multiplying by each time? 1 over 3, right? I think about the numerator. It's always just 5, so it's like 1 on the numerator. And then on the denominator, I have 3, 9, 27, 81. So those are being multiplied by 3. So I'm multiplying by 1/3 each time. So yes, this one ends up being geometric as well. And R is equal to 1/3. See how it's in common? Like you're always multiplying by 1/3. So you can do a bunch of work and you can say, oh, I know that each term, so 5 over 81 divided by the term before it, divided by 5 over 27, that gets my common ratio, which is 5 over 81 times 27 over 5. Reduce, 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 and you end up getting 1 over 3. You can do it that way, but it's much faster just to look at it and say, how did I change? By going here to here, I multiplied by 1/3. Do you understand what I'm saying? Like, don't do the divide by, like, one term divided by the term before. All right, so next up. So in order to find the nth term, when we talked about the arithmetic sequence, we said we start with the first term and we add on those swoops. We add on the common differences n minus 1 times, right? So if I wanted to go from the first term to the 10th term, I added on the swoops 9 times. Same thing for this, but I'm not adding. What am I doing? I'm multiplying. So I'm going to have A1 and I'm going to multiply by R n minus 1 times. So I start with my first term and I multiply by my R n minus 1 times. So let's think about some examples. If I start with the first term and I'm trying to get to the 10th term, I have A1 times R to the 9th. If I start with the, let's say, the 4th term and I'm trying to get to the 12th term, how many R's would I multiply by? R to the 8, right? Do you see how it works? The 25th term, if I start with the 13th term and I'm trying to get to the 25th, how many times do I multiply by R? 12, right? Do you see how it works? I don't know why I wrote such a big space there. All right, so don't just memorize the formula. Know how to go from various terms to other terms. You're thinking, how many swoops do I have? How many times am I multiplying by R? Okay, so the first example, it says find the common ratio of the geometric sequence with A1 equals 3 and A2 equals 12. So I have 3 and I have 12. Okay, list the first 5 terms of the sequence. I don't need to find a formula. All I need to do is identify what my R is. What am I multiplying by? 4, yeah. So if I want to get the next 3 terms, I just continue to multiply by 4. So I'm going to have 48, right? And then 48 times 4 is 192, and then times 4, 768. Those are the first 5 terms. Done. All right, so the next example wants us to find the first 5 terms, but it also wants to write a formula. It wants us to write a formula for the nth term. Okay, so it says write a formula for the geometric sequence where you have the first terms are 3 and -3/4, and then find the first 5 terms of the sequence. Okay, so I have 3 and I have -3/4. Dot, dot, dot. Can you tell what R is? What am I multiplying by? I heard someone mumble.
-1/4.
-1/4. Good job. So I'm multiplying by -1/4. So if I want to get the nth term, I set it up by saying, oh, well, I could start with the first term and multiply by r n minus 1 times. So the nth term is going to be 3 times -1/4 raised to the n minus 1. That's the formula for the nth term. But if I want to find the first 5 terms, I don't have to use that formula. I could plug in like 3 to find the third term. It'd be 3 times -1/4 to the 2. I could do that. But isn't it much easier just to continue to multiply by -1/4? So what happens if I multiply by -1/4? What do I get for my third term? Top is 3, bottom is 16, right? So I'm going to have 3 over 16. All right, what if I multiply that one by -1/4? So 3 over 16 times -1/4. What's my next one? -3 over 64. Yep, and then the last one? Yep, so by -1/4, I get 3 over 256. Good job. Okay, those are the first 5 terms. Okay, but you don't always have the first term. That's nice when you do, because it's pretty easy to write those first 5 terms when you are given the first term. Sometimes you have, like in this case, the fourth and the 7th terms. So the fourth term is -18. And the 7th term is -486. So just like we did in the last section, whatever terms you have, you need to write an equation that relates those two things. So I want to write an equation that relates the fourth term to the 7th term. So in order to go from the fourth term to the 7th term, I'm going to multiply by r. How many times? 3. Right? 3 swoops to go from the 4th to the 7th. So I'm going to have, oops, go away. I'm going to have a sub 7 is -486 equals a sub 4 is -18 r cubed. So I'm going to divide by -18. So -486 divided by -18, I think it's 27. Is that right? So I get 27 equals r cubed. And I need to solve for r, so I'm going to take the cube root and the cube root. So I get r is equal to 3. Okay, r is what you're multiplying by each time. So I have the fourth term and I have the 7th term. I want to find the 5th and the 6th. I want to find the 2 terms between them. Okay, you can set up a formula to find the 5th term. Or you can just think my 4th term is -18, and then I have a blank, and I have a blank, and then I have -486, right? This is a5, and this one's a sub 6. You see what I'm doing there? Right, if I have the 4th and I have the 7th, I have to go through the 5th and the 6th. So I'm going to multiply by 3 each time. So -18 times 3, -54 times 3, -162. Those are the 5th and 6th terms. Does that make sense? So don't do more work than you need to. You don't have to write the formula if you can get it from there. All right, so same thing on this one. Big numbers. I like to put big numbers on the test too, because I'm mean. All right, so I have the 5th term. So a sub 5 is 327,680. Is that a 3 there? Yeah. And then my 7th term is 1,310,720. So I need to write an equation that relates those two things to each other. Okay, so I'm going from the 5th term to the 7th term. How many swoops do I need? 2. So I'm going to do a sub 7 equals a sub 5 times r to the 2nd. I always write down that formula. All right, the 7th term, 1310720 equals 327,680 r squared. All right, and you think it's going to be a big number when you divide it out. It's actually just 4. 4 is equal to r squared. So what is r? 2? Oh, just 2? Ah, it's plus or minus. So when I take the square root, remember a square root or a 4th root, any kind of even root, you need plus or minus. So let's think about what that would be if it was a plus or minus. So if I had 3, 2, 7, 6, 8, 0, don't write this, and then I have something, and then I have 1, 3, 1, 0, 7, 2, 0, and then I have something, right? If R is 2, right, then I get 3, 2, 7, 6, 8, 0 times 2. I get 6, 5, 5, 3, 6, 0, and then when I multiply by 2 again, I do get this, so we're good. But if R was negative 2, then I get negative there. We don't know which one it is. It could be what we call an alternating series. So let's put that in parentheses. So could be alternating. If it's alternating, then the R is negative 2. Each time it's going to go plus, minus, plus, minus, plus, minus, plus, minus. Does that make sense? But we don't know. We were given A5 and A7. All of the things with odd subscripts are going to be positive. But the even ones, we don't know if they're positive or negative. Do you understand what I'm talking about? Do you guys get that? Okay, so now I want to find the first term. So if I'm finding the first term, A1, I need to relate it to one of the two things I was given. So let's say A5 equals A sub 1 times R to the 4th. Okay, let's set it up like that. So A sub 5 is going to be 3, 2, 7, 6, 8, 0. A1 we don't know, and R is either plus or minus 2 to the 4th. Because you're going from the first term to the 5th term. You could go from the first term to the 7th term, but then it'd be R to the 6th, right? Okay, yeah, you with me? Yeah, what's 2 to the 4th? Thank you, Faisal. All right. Yeah, what's negative 2 raised to the 4th? No. No. That'd be 2 to the negative 4. Negative 2 to the 4th is also 16. It doesn't matter what you have. When you do positive 2 to the 4th, you get 16. When I do negative 2 to the 4th, I also get 16. So either way, this is A sub 1 times 16. So when I divide it out, divide by 16, I get A1 is equal to 20,480. That's weird for. Fix it. So 20,480. Okay, should it be plus or minus? No. Because this had an odd subscript. All of those are positive. But what if I found like A sub 2? Well, then that one could be a plus or minus, right? Do you guys understand what I'm saying? Like all of these odd subscripts are positive in this case. Okay. All right, next up. So you guys tried the same thing on number 5. Go ahead and do your setup. This one will be a plus or minus, yeah. All right, so you have the 5th term is 32 over 27, and the 3rd term is 8 over 3. So hopefully you guys are past your fraction phobia from the very beginning of the year. Are you guys good with fractions now? Mm-hmm. All right, so the 5th term is going to be A3 times R squared. That's how you get to the 5th term. So A3 is going to be 8 thirds. A sub 5 is 32 over 27. So if I want to solve this equation, I need to first get rid of my 8 over 3. So I can divide by 8 over 3, which is the same as multiplying by 3 over 8. So I'm going to have 32 over 27 times 3 over 8 equals R squared. And lots of things are going to reduce. So my 32 and my 8 reduce down to 4. And then my 3 and my 27 make the 1 over 9. So I get 4 over 9 equals R squared. So now I take the square root. Square root, square root. Whenever I take a square root, I do plus or minus. So I get R is equal to, right, I take the square root of the top and the bottom. So square root of 4 is 2, square root of 9 is 3. So I get 2 thirds. So now I have my R. So I'm asked to find the 2nd term. So I can use anything, yep. Oh, I forgot my plus or minus after I already talked about it. Jenny gets a point, man. That might be her 5th point too. I feel like you're up there. All right, so I get my R as plus or minus 2 thirds. So I'm going from the 5th term to the 3rd term, and now I want to go to the 2nd term. I can use either the 5th or the 3rd. It doesn't matter. I use the one that's closer. I'm going to use the 3rd. So A3 is going to equal A2 times r to the first. So A2 is the one we don't know. R is plus or minus 2/3. Do you guys understand that that's times? Like you can put a little times mark if that bothers you. You're not adding 2/3 and subtracting 2/3. All right, and then A3 is going to be 8/3. So if I want to get rid of the 2/3, I'm going to multiply by plus or minus the 3/2. So I have 8/3 times plus or minus 3/2. And my 3 and 3 reduce out. And my 8 and 2 reduce out and give me 4. So I get A2 is equal to plus or minus 4. So it could be either one. So look at your subscripts. Your fifth term and third terms were positive numbers. Those are the subscripts that are odd, right? The evens could be either plus or minus. It's either an alternating sequence or they're all pluses. Yeah.
You took that.
I did because I wanted to divide by 2/3. So that's the same as multiplying by 3/2. All right, so let's talk about adding terms together. Okay, so if I want to add a sequence together and it's a geometric sequence, I can't use that Gauss formula. Remember Gauss? Gauss is the one that had 1, 2, 3, all the way to 100, and he paired things together, and he said 101, right? That does not even come close with a geometric. Imagine I have a geometric sequence. Like if I have 1, 2, 4, 8, 16, 32. If I just have those. These make 33. What do 2 and 16 make? Not 33, they make 18. You can't pair the first and last together. So we can't use the Gauss formula for a geometric. So there's another formula that we learned. So before we learn this formula, we're going to talk about, well, what if we had the same thing all the time? What if I had the sequence that looked like 5 plus 5 plus 5 plus 5 plus 5, and I go 100 times? So if I just have the sequence 5 plus 5 plus 5 plus 5 plus 5, and I add 100 5s together, what do I get? 500. We all know that, right? So the same idea, what if I have A1, and then the next term is A1, and then the next one's A1? What's your common ratio in this case? What am I multiplying by to go to the next thing? Just 1, right? So this would be if your common ratio is 1, and then I have this k times. Well, then the sum would be A1 times k. So when your sequence has a common ratio of 1, it's really not that interesting. You're just adding the same term to itself however many times. Okay, not interesting. Okay, we're going to talk about when we don't have it equal to 1. So that's why in this formula it says r is not equal to 1. So it says the sum of the finite geometric sequence A1R, or A1, comma A1R, blah, 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 is given by S sub n equals A1 times 1 minus r to the n all over 1 minus r. This is the only formula I will give you on your test. That's it. You got to know everything else. All right, so for this first example, I have negative 5/2 plus 5/4 minus 5/8, and so on. So in order to find the sum of all the terms, I need to know 3 things. I need to know A1, I need to know R, and I need to know N. What's A1? Negative 5/2, right? What's R? What am I multiplying by each time? Negative 1/2. Do you guys see how the top I multiply by negative 1? It goes negative 5, 5, negative 5, 5, negative 5, 5. And then on the bottom I have 2, 4, 8, 16, 32. I'm multiplying by 2 on the bottom. So my ratio is negative 1/2. How many terms do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 terms. So I'm adding, and I'm finding the sum of those 9 terms. So I can do it with this formula. Now this one wouldn't be hard to put all in your calculator all at once and just add those terms together. But when you have like 500 terms, right, you don't want to do that. So I'm going to have A1 is negative 5/2. I'm going to multiply by 1 minus R, which is negative 1/2, to the n, so 9, all over 1 minus R. I always put my R in parentheses because if R is a fraction, right, I need that whole fraction raised to the 9th. If r is a negative, I need the negative raised to the ninth. Okay, so I always put r in parentheses. Okay, people always set this up right on the test and then they miss it because they put it in wrong on their calculator. So get your calculators out and let's try this. Yeah, Caroline.
Is there like a reason that you're doing it to us on like this?
Because it's the hardest one to memorize. So I don't have to, I guess. A lot of people, when they try to memorize it, instead of doing r to the n, they do r to the n minus 1. So, all right, so typically when I put this into my calculator, what I do is I put in the bottom first, just so I can know what that is, so I can divide it out later. So I have 1 minus a negative 1/2 is 1.5, or 3/2. Okay, then I put in the top second, and then at the end I multiply by this. Okay, so I'm going to do the top. So I'm going to do 1 minus parentheses negative 1/2 raised to the 9. So when I do that right now, I have 1.001953125. That's what it says on my calculator. Okay, that's just the numerator. I'm going to divide by 3/2. Now, if I'm dividing by 3/2, I need to put it in parentheses. So make sure you do divide by parentheses 3/2. Or you could divide by what decimal? 1.5, right? You could do that if you want to as well. If it's like 1.3 repeating, I wouldn't do a decimal. I would do divide by 4/3. Okay, so right now I have 0.66796875. Okay? Now I'm going to multiply by my negative 5/2. So multiply by negative 5/2. And when I do, I get S sub 9 is equal to negative 1.6699. Okay, I always try to get it as a fraction if possible. So at this point on your calculator along the left-hand side, there's the math button. So hit math, and then change it to a fraction. So math 1. This is the answer that I prefer, negative 855 over 512. Does it make sense why our common denominator was 512 looking at the original? Yeah. So yeah, you have 2, 4, 8, 16, 32. You can get them all to be 512 and then you can combine. So that's what's happening. Sometimes your calculator can't handle the number of digits it has and it won't give you the fraction answer. If that happens, just do it to like 3 decimal places. I'm fine with that. All right, so there's always interesting questions about geometric sequences because geometric sequences can grow really, really fast. Okay, so here's an example of one. I made this problem, I don't know, like 5 years ago, and I've kept it in the notes since. I kind of like it. And I didn't know when I made it. I was like, yeah, we'll see which one's bigger. I have no idea. Okay, so it says, would you rather get paid $10,000 every single day for 30 days? So how much would I have after 30 days? Nope. 300,000. Not $1 million every for 30 days. That's right, 300,000. Or would you rather get paid a penny the first day, 2 pennies the second day, 4 pennies the next, 8 pennies, 16 pennies, and so on? And personally, when looking at this, I'm like, I want this sure thing. I want this like 30 days of $10,000. I would love to make $300,000 in a single month. That would be pretty exciting. That's totally my salary as a teacher, you know, not at all. Okay, so let's see on the second one. So some people are saying the second just because you think I'm tricking you. Maybe I am. I just made this up. I don't know which one's closer. All right, but now I've done it like 5 years. So yeah, I do know which ones, but whatever. All right, so do you guys agree that this is a geometric series? It's the sum of a geometric sequence. What is R? What am I multiplying by? 2 every single time. What's my first term? 1 penny, so 0.01, 1 cent. And how many terms am I going to add together? What's n? 30. I'm adding up the first 30 days. So you guys can do this with your mom. You can go home and be like, Mom, I've decided I really want to help you out for this next month around the house. And the first day, just give me a penny. Tomorrow, give me 2 pennies. The next day, give me 4 pennies. And then 8 pennies and so on until the end, until 30 days. And your mom might be like, okay, that sounds good. And I'd say, okay, let's sign this in a document. Let's put our signatures on here. All right, sorry, moms of the world. All right, so here's what we're going to do. So we're going to find the sum after 30 days. So I have my A1, which is 0.01, and I'm going to have 1 minus R, which is 2, raised to the 30, all over 1 minus 2. So in this case, you don't really need parentheses around that too, but I just typically like to put them in just to be consistent. If I had a fraction or if I had a negative, it would be important. So I'm going to have 1 minus 2 raised to the 30, huge, huge number, divided by 1 minus 2 is negative 1, so divide by negative 1, times 0.01. So after 30 days, you have 107,37418.23. $10,737,418.23. How does it happen? So, I don't know. If you just want to figure out how much you make on the 30th day, if you just want to define that, well, that's what we did at the beginning of the section, right? That's when we said, okay, we start with A1 and we multiply by R to the 29. So A1 is 0.01, R is 2, so 2 to the 29. In that single day, you would make over $5 million. That's how much money you make on that very last day. Okay, so it does. It works out pretty quickly. And you can try it if you want to do that off, in your additional notes or something and do 1 cent, 2 cents, 3 or 4 cents, 8 cents, so on. It gets big super fast. Okay. All right, so then the last little bit. So the last little bit of this section says, well, what if you have an infinite sequence? Can you add up an infinite number of terms? And in this case, you couldn't. Like, you can't say, well, how much would you have after an infinity number of days? Right? You have an infinite number of dollars, right? It just gets out of control. It gets big, huge, fast, right? So the question is, can you add up an infinite number of terms? And you can. So here's the typical example I like to show people. You don't have to draw this or write this on your notes. You just have to kind of think about it. So here's the example I always show. 1 plus 1/2 plus 1/4 plus 1/8 plus 1 over 16 plus ... That ends up being a number, a nice number, not infinity. Okay, and here's what's happening. If I draw a number line from 0 to 2, visually, if I want to add in 1, here's where 1 is, and then I want to add 2, or if I want to do 1/2, then I do another 1/2, and if I want to add in another 1/4, I have 1/4, and 1/8, and 1 over 16, and 1 over 32. Do you guys see what's happening? 1.99999, that's what I hear some of you guys say. 1.9 repeating is actually 2. It goes to 2. 0.9 repeating is actually 1. I will show you like 3 proofs at the end of this on why that's true, why 0.9 repeating is 1. I know, it's hurting your head, isn't it? Abby's like, no! It's like killing everything that you've ever thought of. Here's an easy proof. Do you guys agree that 0.3 repeating plus 0.3 repeating plus 0.3 repeating is 0.9 repeating? Yeah, it's 0.9 repeating, right? 3, 3, 3, 3, 3, 3, 3, 3, 3. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. When I add those together, all of the 3s line up, right? I could do. You agree with me? It becomes 0.999 all the way. But that's 1/3 plus 1/3 plus 1/3, which is 1. Oh, yes. You're kind of starting to believe me a little bit. All right, so we'll talk about that. Yeah.
I told my friend this, and we ended up doing like an hour thing when he was trying to prove it wrong.
Okay, well, I will show you 4 proofs that make it true.
I did those to get extra credit.
Did you?
7th grade.
Good. All right, with Mr. What's his name? Yeah, the guy I worked with over the summer, Craig. Mr. Craig something.
His name is just Craig. Craig.
I want to say Blossom.
Oh, I'm not Mr. Blossom.
Okay. Is that the first name? Okay. All right, anyway, so here we go. So here we go. So the sum of an infinite geometric series. So this sum ends up being A1 over 1 minus R. Okay, and the reason is because it's related to that S of n equals A1, 1 minus R to the n over 1 minus R. It's related to it. But what we do is we say R to the n is equal to 0. So it says, shh, guys, it says this is because n gets very large, which means a small fraction raised to n becomes almost 0. So let me show you something on your calculator. On your calculator, I want you to do 1/2 to the 100. So put your parentheses, 1 over 2, raised to the 100. When we do this, I get 7.889 times 10 to the negative 31. So it's a tiny, tiny number. 10 to the negative 31. That's 0.300789, or 7889, right? Tiny, very, very close to 0. Now your calculator is going to lie to you when you do 1/2 raised to the 500. What does your calculator tell you that it is? It says 0. Is it equal to 0?
No.
No, it's actually 1/2 to the 500, which your calculator can't handle that number of digits, and it tells you it's 0. That's what's happening in this formula. As long as r is less than 0, or less than 1, I mean, sorry, the absolute value of r is less than 1. So I have numbers like 1/2 or negative 1/2, 3/4, negative 3/4, something like that. Then this series does what we call, it converges. It becomes a nice finite number. And what happens is when you take a tiny number, r, and you raise it to a huge number, infinity, or you could do 5 trillion or something like that. If I do 1/2 to the 5 trillion, it's so close to 0 that it doesn't matter. It becomes insignificant in the formula. So all of that goes away. So you have a1 times 1 minus 0, which is a1 times 1 over 1 minus r. So it's a1 over 1 minus r. That's where the formula comes from. Okay? So in this example, I have 1/2, 1/4, 1/8, and so on. I want to find the sum of the infinite series. So my a1 is 1/2. What's my r? What am I multiplying by each time? 1/2. So I have a1, which is 1/2, over 1 minus 1/2. So I get 1/2 over 1 minus 1/2 is 1/2. So my answer is 1. You with me, Aya? Yeah.
So you can only do this for r's that are fractions.
You can only use r's that are smaller than 1. If it was like 1.1, it's going to diverge. It's going to go off to infinity. Okay, so if I plug in for the next one, if I need to see the first few terms for this, I always recommend if you have a sigma, you write out the first couple terms. Kind of like your quiz. You had 0.3 plus 0.03 plus 0.003, right? That ended up adding to be 0.3 repeating, which was 1/3. Okay, so let's write out the first couple terms on this. If I have 2 times negative 2/3 to the 0, negative 2/3 to the 0 is 1, times 2 is 2. Okay, plus, what if I have 2 times negative 2/3 to the 1? Well, that's 2 times negative 2/3. So 2 over 1 times negative 2/3 is negative 4 over 3. Then what if I have negative 2/3 to the 2? Well, that's going to give me 4 over 9 times 2, so I'm going to get 8 over 9, and then so on. So we saw the first couple terms. Can you identify the different pieces? Can you find a1 and can you find r? What's a1? What's r? Negative 2/3. It's what you're, see how you're gaining another 2/3 every single time you put in a different number for n? Like if you plug in n equals 1, you only have 1 2/3, but if you plug in 2, you have 2 negative 2/3. So you're gaining another negative 2/3. So your sum is going to be a1, which is 2, over 1 minus a negative 2/3. So you get 2 over 1 plus 2/3. What's 1 plus 2/3? 1 and 2/3 is 5/3, right? So you have 2 divided by 5/3, which is 2 times 3/5. So what's my answer? 6/5. So this series converges and it goes to 6 over 5. Okay? So really quickly, let's talk about, you can flip to your additional notes. Let's talk about why 0.9 repeating is equal to 1. I'm going to show you a couple different proofs. Okay, so 0.9 repeating. So let's first use our calculator to find a few things. So let's do 1/9 on our calculator. What do you get? So do 1 divided by 9 on your calculator. Do you guys see how it's 0.1111111? So that's 0.1 repeating. 2/9. 2 over 9 is 0.222222. 3/9, right? We know that one. That's 0.3 repeating because it's the same as 1/3. What about 4/9? What's your calculator tell you? What do we think? 0.4 repeating. 5/9. Now your calculator starts to kind of lie to you on this one. it says 0.5555555, and then it rounds up to 6. So it's rounding at the end. So that's okay. It's still the same, 0.5 repeating. So we think 8/9 is going to be 0.8 repeating, which it is, and 9/9 then would be 0.9 repeating. But what's 9/9? 1. So 0.9 repeating is equal to 1. That's our first proof. Our second proof is the one that I told you before. If you have 1/3 plus 1/3 plus 1/3 as decimals, that's 0.3 repeating plus 0.3 repeating plus 0.3 repeating, which is 0.9 repeating, but 1/3 plus 1/3 plus 1/3 is 1. So 1 is equal to 0.9 repeating. You could do the same thing for any of these fractions. Like, you could do 0.1 repeating plus 0.1 repeating 9 times, right? 0.1 repeating plus 0.1 repeating plus 0.1. If I did that 9 times, I'd have 0.9 repeating. But 1/9 times 9 gives me 1. So it works the same way. All right, and what we typically will do for these decimals that repeat is we let x equal one of them. So let's do it for 0.2 repeating. So let x equal 0.2 repeating. Do you guys see how 0.2 repeating is going to be 0.2, 2, 2, 2, 2, and so on? But when I multiply by 10, like if I asked you to find 10x, whenever we multiply a number by 10, you just move the decimal place over. So I'm going to move it right over here. So I'm going to have 2.2 repeating. Do you see that? This is a trick we do to find the fraction form of any repeating decimal. So even if I had 0.12 repeating, I can do this trick. I would let x equal 0.12 repeating, but then in that case, I'd have to multiply by 100. So then I have 12.12 repeating. So however many numbers you have repeating, that's what you want to multiply. Like, you want to do like 100 if you have 2 things repeating, or 10 if you have 1 thing repeating. Okay, anyway, so back to here. So I'm going to multiply, or I'm going to subtract these 2 things. So I have 10x equals 2.2 repeating. And if I subtract that other equation out, 10x minus 1x becomes 9x. What is 2.2 repeating minus the 0.2 repeating part? What do I get? Do you see how it's just 2? So x then is 2/9. So that proves it. So let's do the same thing, but let's say let x equal 0.9 repeating. If x is equal to 0.9 repeating, then 10x is equal to 9.9 repeating. So when I subtract, so if I have 10x equals 9.9 repeating, and I subtract an x, then I get 9x equals just 9. So x is equal to 1. Okay, last proof. 0.9 repeating. Well, that is 0.9 plus 0.09 plus 0.009, and so on. This is a geometric sequence. A1 is equal to 0.9. What's R? How do I go from here to here? What do I multiply by? By 1/10, or 0.1. So let's do 1 over 10. So the sum ends up being A1 over 1 minus R, which is 0.9 over 1 minus 1/10, which is 0.9 over 0.9. So your sum is equal to 1. So we just proved that 0.9, again, is equal to 1. Does that make sense? Now you can go home and tell your parents that one too.